In section 2.6, we are going to look at the double angles and half angles. So if theta is given to us, then we want to know in relation to theta what is in the question. So if theta is given, then the question is about 2 theta. We say we are using double angle formulas. But if theta is given and the question is about theta over 2, then half angle is in the question. In either case, it's always wise to look at the quadrant where theta is, where theta over 2 is. Sometimes it's also helpful to see where 2 theta is, and completing x, y, r, or in some cases we just use identities. So the formulas, I wrote 3 of them here, but you know that there are more from the notes and from the PowerPoint. For example, for cosine of 2 theta, not only it's cosine squared of theta minus sine squared of theta, but it could also be 2 cosine squared of theta minus 1. It could also be 1 minus 2 sine squared of theta. So the more formulas that we have, the more power that we have actually to solve these type of questions, because if only sine of theta is given to us and the question is to find cosine of 2 theta, then I can just go directly use this formula, the last one that I wrote, 1 minus 2 sine squared of theta, without having to go through finding the cosine of theta and work with the original formula. So I have the option of just staying with the information that is given to us and work with 1 minus 2 sine squared of theta. So let's look at an example here. You see that if sine of theta is given to us 1/6, theta is from 0 to pi over 2. That tells me that theta is in first quadrant, greater than 0, less than pi over 2. Okay, good. So in first quadrant, everything is positive. Sine is positive, cosine is positive, tangent is positive. And because of that, all the reciprocals, which are cosecant, secant, and cotangent, they're also positive. So no problem there, everything is positive, but we did pay attention to this quadrant. Now I write the formula. The question is, what is sine of 2 theta? Well, for 2 theta, we know that formula is 2 sine theta cosine theta. Now, sine of theta is already given to us. It's 1/6. But we don't have cosine of theta. If we find cosine of theta, then from there we can just substitute and answer the question about sine of 2 theta. So for now, we put this sine of 2 theta on hold. Let's go and find cosine of theta. Let's say we want to do x, y, r. In order to work with x, y, r, here sine is given, and we know that sine is y over r. So basically, we know that y is 1, r is 6, and we know that they're both positive. It's quadrant 1, so y is positive, and x is going to be positive 2 when we find it. Let's complete that. We know that the equation that bounds these 3 is x squared plus y squared equals r squared. Substituting numbers, we have x squared plus 1 squared, which is 1, equals 6 squared, which is 36. So then x squared is 35, or we can say x is positive negative square root of 35, but we already said that because it's quadrant 1, it can't be negative. So it's just positive square root of 35. But you see, it wouldn't have been possible if I hadn't paid attention to the fact that here we are working with quadrants, and quadrants are important. And because it's in quadrant 1, then we can say that x is positive. That's a very important part. Okay, so having x, y, r, then it means that cosine of theta, which we know it's x over r, then by value it's square root of 35/6. Now we have cosine of theta. Sine of theta was given to us from the beginning. Now we can put it into this formula. So the question can be answered. Question was, what is sine of 2 theta? It's 2 times sine of theta, which is 1/6, cosine of theta, which we found to be square root of 35/6. Multiplying these 3 fractions, I'm going to simplify 2 and 6 to get 3 here. So it's square root of 35 in the numerator, 3 times 6, 18 in the denominator. And that's sine of 2 theta. So that's how we are finding these values. That's how we are substituting using XYR. I also said you can use identities. Let me show you how we would use the identity to find cosine of theta. For that matter, we see that sine of theta is given to us, and we already know that sine squared of theta plus cosine squared of theta is equal to 1. So for any angle theta, it doesn't have to be called theta. So here we say 1 over 6 squared plus cosine squared of theta is equal to 1. From here, we are solving for cosine of theta. So 1/6 squared is 1 over 36. So let's subtract it from both sides. One is 36 over 36. So this one gives us 35 over 36. Then doing the square root of both sides, we find cosine of theta is square root of 35 over square root of 36, which is 6. And as I explained earlier, because theta is in quadrant 1, when we do square root, we are going with the positive value for cosine. So you see, it doesn't matter if I do XYR or if I use identity. I'm finding the same value for cosine in both cases. So that's how we solve going from theta given to its double.